Hey everyone, Linus here. Today we're diving into the world of Voltage Regulator Modules, or VRMs for short. These little guys are the unsung heroes of your motherboard, quietly ensuring your CPU gets the clean, stable power it needs to run like a champ. Without VRMs, your computer would be a stuttering, crashing mess. Imagine your CPU as a high-performance sports car. It needs the right kind of fuel, delivered at the right pressure to reach its full potential. That's where VRMs come in. They act like a sophisticated fuel injection system, taking the raw power from your power supply and converting it into the precise voltage required by your CPU. But it's not just about delivering power, it's about delivering it cleanly and consistently. The power coming from your wall outlet isn't exactly pristine. It fluctuates and has noise which can mess with your CPU's performance and even damage it over time. VRMs smooth out these imperfections, providing a steady and reliable flow of power to your processor. So, how do these magical VRMs actually work? Well, they're made up of a few key components, each playing a crucial role in the power regulation process. Let's break it down. First up, we have MOSFETs, or metal oxide semiconductor field effect transistors. Don't let the fancy name scare you. Think of them as tiny electronic switches that rapidly turn the power on and off. By controlling the frequency and duration of these on-off cycles, MOSFETs regulate the voltage delivered to the CPU. Next, we have chokes, also known as inductors. These guys act like electrical shock absorbers, smoothing out any sudden changes in current. They store energy when the current is high and release it when the current drops, ensuring a consistent flow of power. Finally, we have capacitors, which are like tiny energy reservoirs. They store electrical charge and release it quickly when needed, helping to maintain a stable voltage even during sudden spikes in CPU demand. Now that we know the players, let's see how they work together to keep your CPU humming along happily. The process starts with the power supply, which delivers a base voltage to the motherboard. This voltage is typically 12 volts, which is way too high for your delicate CPU. This is where the VRM steps in. The MOSFETs, controlled by a dedicated chip on the motherboard, start switching the incoming power on and off at incredibly high speeds, often thousands of times per second. This rapid switching creates a pulsating current. The chokes then step in to smooth out this pulsating current, filtering out noise and voltage spikes. Meanwhile, the capacitors store and release energy as needed, further stabilizing the voltage. The end result is a clean, consistent flow of power delivered to your CPU at the precise voltage it requires. It's like taking a wild, untamed river and channeling it through a series of dams and reservoirs to create a calm, steady stream. That's what VRMs do for your CPU's power supply. You might be wondering, why go through all this trouble? Can't we just give the CPU the raw 12 volts and call it a day? Well, not really. Modern CPUs are incredibly complex beasts, with billions of transistors operating at lightning-fast speeds. They require specific and often very low voltages to function correctly. Using a higher voltage than necessary would generate excessive heat, potentially damaging the CPU and reducing its lifespan. On the other hand, insufficient voltage would lead to instability, causing crashes and errors. VRMs ensure that your CPU receives the exact voltage it needs, right when it needs it. This precise power delivery is crucial for maintaining optimal performance, allowing your CPU to run at its full potential without overheating or crashing. Moreover, with the increasing core counts and clock speeds of modern CPUs, the demand for clean and stable power has never been higher. A robust VRM is essential for handling the power-hungry nature of today's processors. Section 5. Unleashing potential VRMs, overclocking and gaming. Speaking of power-hungry CPUs, let's talk about overclocking. For the uninitiated, overclocking involves pushing your CPU beyond its factory-set speeds to squeeze out extra performance. It's like injecting your sports car with nitrous oxide. You get a boost, but it puts more stress on the engine. Overclocking requires a higher voltage to maintain stability at those increased speeds. And guess what? A beefier VRM can handle those higher voltages and currents like a champ, providing the stable power delivery necessary for a successful overclock. Gamers, this one's for you too. Demanding games can push your CPU to its limits, causing it to draw more power. A robust VRM ensures that your CPU gets the juice it needs to maintain peak performance even during those intense gaming sessions, preventing lag and frame rate drops. Section 6. Spotting a good VRM. Tips for motherboard selection. Now, how can you tell if a motherboard has a good VRM? Here are a few things to look out for. Number of phases. More phases generally mean better power delivery and heat dissipation. Aim for at least 6 phases for a mid-range CPU and 8 or more for high-end processors, especially if you plan on overclocking. Component quality. Look for motherboards using high-quality MOSFETs, chokes, and capacitors. These components might cost a bit more, but they offer better efficiency, longevity, and stability. Heatsinks VRMs generate heat, especially under heavy load. A motherboard with substantial heatsinks on the VRM components will dissipate heat more effectively, ensuring cooler operating temperatures and improved longevity. Don't hesitate to do your research and read reviews before buying a motherboard. Pay attention to what experts and other users have to say about the VRM quality, especially if you're building a high-performance system or plan on overclocking. Section 7. VRM phases. More power, better performance. You've probably heard the term VRM phases thrown around, but what does it actually mean? In simple terms, each VRM phase is like a separate power delivery channel for your CPU. Think of it like having multiple lanes on a highway. More lanes mean smoother traffic flow, even during rush hour. Similarly, more VRM phases allow for better current distribution, reducing stress on individual components and improving overall efficiency. A motherboard with 8 phases, for instance, can share the load of powering a CPU across 8 separate channels, while a 4-phase VRM would have to handle the same load with only 4 channels. This means each phase in the 8-phase VRM carries less current, resulting in lower temperatures and potentially longer lifespan for the VRM components. However, it's not just about the sheer number of phases. The quality of the components and the overall VRM design also play a significant role in determining its performance and efficiency. Section 8. Beyond the specs, VRM quality and long-term reliability. While specifications like the number of phases and component brands can give you a general idea of VRM quality, there's more to it than meets the eye. The overall design, layout, and manufacturing quality of the VRM also play a crucial role in its long-term reliability and performance. A well-designed VRM will have a clean layout with minimal signal interference, efficient heat dissipation, and high-quality soldering. These factors might not be immediately apparent from the spec sheet, but they can significantly impact the VRM's lifespan and stability. This is where reputable motherboard manufacturers with a proven track record of quality and reliability come in. They invest in research and development, ensuring their VRMs are designed and built to last even under demanding conditions. Remember, a good VRM is an investment in the long-term health and performance of your system. It's worth spending a bit extra for a motherboard with a reputable VRM, especially if you're building a system that you plan on keeping for several years. Section 9. Wrapping it up, choose your VRMs wisely. So there you have it, folks. VRMs might be hidden beneath heat sinks and shrouded in technical jargon, but they play a vital role in the performance, stability, and longevity of your computer. Whether you're a casual user, a hardcore gamer, or an overclocking enthusiast, choosing a motherboard with a good VRM is crucial for ensuring a smooth and enjoyable computing experience. Remember to consider the number of phases, component quality, heatsink design, and the manufacturer's reputation when making your decision. By understanding the importance of VRMs and making informed choices, you can ensure your CPU gets the clean, stable power it needs to unleash its full potential. Until next time, happy building!